Hello and welcome to this technical spotlight brought to you by Dicker Data and NVIDIA. My name is Voldis, Solutions Architect at Dicker Data. I'm joined here today by Ian, Solutions Architect at NVIDIA. Today we are looking at the future of AI networking.
Thanks, Voldis. Great to be here. There's a lot of exciting things happening at NVIDIA at the moment with the full stack accelerated computing platform. So glad to be here to start talking NVIDIA networking products.
So Ian, can you give us a high-level overview of NVIDIA's networking products and where they sit in the market?
Yeah, sure, mate. So at NVIDIA, we take this holistic approach to AI workloads with a full stack accelerated computing AI infrastructure comprising of not only hardware, but the software and networking as well. We're working to address and accelerate every component of the stack as we move into the age of agentic AI and the demands to be more accurate with AI. AI reasoning models have popped up in the past year. These models have increased in orders of 8 to 10x in token generation over previous transformer-based large language models. As such, with the requirements for more token processing, compute and data centers need to scale out. And this is where networking comes in, but not any traditional Ethernet network will do for the job. For the GPUs spread across multiple systems in multiple racks and all the way to large-scale data centers, they need to calculate and process cohesively in order to ingest or produce these tokens. And this leads to NVIDIA's Ethernet switch product, the next generation Spectrum X, purpose-built and designed for AI workloads of the future.
It's the backbone of the modern data center.
Absolutely.
That's a powerful foundation. So how do NVIDIA's products integrate with your GPU technology to enhance data processing and resource utilization?
Yeah, so NVIDIA networking is key for GPU infrastructure to communicate, process, and calculate with other GPUs across the entire data center. It is required to be purpose-built for AI workloads to ensure that the packets of information is lossless, jitter-free, low latency, and we need to ensure that we have a fair bandwidth across all the applications within the AI workload across the entire data center.
So you've really addressed every pain point from traditional networking for this.
Thanks.
Let's bring it closer to home. How can NVIDIA's networking technology assist in AI, ML, and HPC in the Australian market?
Yeah, so NVIDIA's networking follows the IEEE Ethernet networking standard, can be interconnected with any system, network product in the industry. So for those AI workloads and especially sovereign AI for Australia, NVIDIA has conducted a wealth of extensive research and development in NVIDIA's engineering labs on purpose-built supercomputers connected with our networking products developed with the NVIDIA Spectrum X. So Ethernet networking for AI.
Which specific sectors stand to benefit the most from these advancements?
Every industry is going to be touched by AI in the future, as we foresee. NVIDIA Spectrum X is designed to adhere to IEEE networking Ethernet standards. Any workload can use it, but where it will shine is AI workloads, as these workloads have a traffic-heavy profile in nature from east-west within the data center, as opposed to our traditional and common workloads which have a north-south profile in nature. And Spectrum X is about 1.6 to 1.7x in performance uplift over traditional Ethernet networks. So that means if you spend $10 million, you'll get a $7 million uplift in performance over traditional Ethernet.
Big savings.
Yeah.
Now, NVIDIA recently announced that the new Spectrum X series switches now have transceivers integrated within the switch. Can you take us through how that works and why it would be beneficial to make this change?
So coming back to NVIDIA's goal to accelerate every component of the full stack in accelerated computing infrastructure, we invested into silicon photonics. This reduces not only the cost of transceivers, but also massive power reductions. Very quickly, customers can realize the savings, not only in CapEx of building out the data center, but also improve reliability due to the transceivers and no longer required. And then with regards to OpEx, you'll have savings there as well due to lower power operations, and most important thing is cooling. So that's some of the benefits of silicon photonics.
Cooling is a very big expense in the data center.
Yes, adds up very quickly.
Very much does. And finally, can you give us some more information around the new Spectrum X range and where that sits compared to the traditional Spectrum range?
The next generation of Spectrum X will bring Ethernet AI networking, some of these value propositions, low latency throughput, and noise reductions because there isn't the need to convert from electrical to optical signals and vice versa. Significant power reductions because that conversion requirement is gone. So you'll be saving at minimum 17 watts per transceiver in each cage of the switch across multiple switches and data center. Also now there will be an increase with the radix, thus creating capability for more GPUs to communicate at greater scale with less hops when traversing the network fabric. We also continue to grow our partnerships with our partners like Dell and Cisco. They'll be releasing their product line of NVIDIA Spectrum X support switches in the near future as well.
Fantastic insights, Ian. Thanks for walking us through the future of AI networking. Stay tuned, everyone. There's more to come from Dicker Data and NVIDIA.